Hello, welcome back to another video of Advent of Code. So I think we're up to day 16 now, so we'll go and start a new day for day 16. Slowly catching up, and they do more every day, but that's how it goes. Now this input has a bit going on to it. I might do a similar thing that I did in the last video and do some Vim magic, I guess. And we could probably do something like that. That font is not great for the eye. Well, I guess the 1 is different, and the L is different, but yeah, like it's very similar to all those letters. Anyway, sidetracking. So what I'm doing is I'm just adding in the, change the dynamic content of the input, and the idea is I will fix it up with Vim stuff to just make it be correct. GG 0 FF HH 122 GG 0 JJ. See, that I, capital I, is quite good because it's got the bar, whereas this capital I is hard to know whether it is an I or an L or something else. Cool, so that is that. What we can do is probably add valve to the start of that, and this we can also probably go as flow rate equals to be that. And here what I might do is go to the start of the line, find how do we find that? I thought it was that key. No, that's right. Find is that key. No. Have we crashed? Oh, my keyboard's stopped working. It wasn't quite plugged in. Go, light up. Right. Turn on and become a keyboard. Technical issue. Right. Unplug that. Turn. It's like trying to turn on, but not fully turning on. Kind of need a keyboard. Oh yeah, it's doing its thing again. It's like maybe I'll turn on. Might just. What I could do is, if that doesn't get in, I can plug it directly into the computer. Will it reach? I think we can get up here. Gosh. Yeah, that sounds better. Made a little. Right, so here we can start that macro. We can go find there, and here we can go to the end of a word, and then append, and then tunnels lead to vowels, then space, then exit, then down one, then back to the start of the line. And I'll just turn this off always on top to make sure I got it right. Right, so I've got an extra space, but that's right. I think I want relative number on here, so I know that I want to do 9 times Q, and here we're actually in a nice spot that we can just go like that, and that should be the input. Cool. So what is the answer? 1651. Part 1 1561, was that right? For 1651. 651. Cool. So, this problem, we can probably get rid of day 15 because we've finished that, and we can maybe close Hack Studio and get it to show what I want it to show. I've noticed Hack Studio, like, it doesn't always like it when you create a file outside of it, I guess, and this, I can have it reasonably big. So day 16, we just start off with that, and we can probably do day 16 example, and it will basically just print out the stuff I just typed in, but it's right, and the input looks a bit bigger. So I had a bit of a read of this. Basically, your elephants become a thing now. So we had monkeys ages back, and now we've got elephants. Weirdly, so I believe we're like in a cave or like a set of tunnels. Yeah, and so we found a sensor. And yeah, right. So we're in a volcano with elephants because elephants just happen to be in a volcano, and we reckon the volcano is about to erupt. So we've only got 30 minutes to get out. Luckily, we can solve everything. Right. So what's happening? We basically got a set of tunnels, and in each tunnel there's like some valves and stuff, and if we open the valve then we like reduce the pressure release valves, and what we want to do is, I believe, try and work out the maximum amount of pressure that we can get out in 30 minutes, which is, for the example, 1651. So, everything begins closed, and we start at AA. I got a spoiler from my workmates also doing this, that they noticed that their first line is not AA, but in the example input it is, and they were trying to go from there. So we'll have to keep that in mind, that we actually want to start from there, AA, which is halfway through. How I think I'm going to do this is parse all the input, build it into some sort of data structure that we can then do some sort of search on it, and then we can basically run that search algorithm and work out the optimal number. How I think I'll go about this is probably reuse a star, which I used somewhere. Get a star, I think I called it, and yeah, day 12 is where I used it, so I might open up day 12, and we're gonna take this and kind of adapt it slightly, because it's not like what's the right word for it, like parameterize, or like we probably could make it more generic, so that we could put any type in. We could probably put in our helpers. I might be too lazy to do that and won't do that, but I can at least take it and work it out. So to parse it, we've got an interesting case of we might not have seen a certain valve when we come to reference it the first time, which is a problem in computer science sometimes. For example, here we're reading valve AA, but then we have paths to some other valves, DD, II, and BB, and there, and there. So what I think we need to do is kind of preemptively create a valve when we see it the first time, and if we're seeing it like on the left hand side of, say, the semicolon or something, we can assign the rate, and if we see it before that, we can just assign a rate of none, so we can have it as an optional type. and by the end of it, all the rates should be correct. In fact, like, we could also just set rate to be 0 and then update it to be whatever the rate actually is. You run into the risk that if your input's not complete, then you might run into issues, but we could probably make the assumption that the input is complete, that all of the things on the right hand side have a corresponding thing on the left hand side. Yeah. As for the state of each valve, so we have a flow rate, and we also have whether they are open or closed. And on top of the kind of notion of a valve, I think we also need like a node in the search space graph, and the node will keep track of how many minutes we have been, so that if we've gone for 30 minutes, we can be like, cool, we have finished. And it can also keep track on the like total flow rate. That might come in the next video, because I'll probably just do the parsing in this video, like I've done in previous videos. So what I will do is maybe pull that there, and we can do this as a class, and we can call it a valve, and I'm going to do it as a class because I want it copied by reference, because I'm pretty sure in day 12 I probably also did classes for things, and I did structure there, and I did structure. Maybe yeah, I don't know, maybe I didn't think. Well, like I kind of, yeah, that's a different problem. But I kind of don't want it to be copied by value, because then I can imagine this expanding out quite considerably, and I need to know that a certain valve is the same valve as when I referenced it the last time, if that makes sense. So I think here we're going to have like a mutable valves, we can call it, and this is going to be a just a set list of valves, and in valve we're going to have flow rate, and this can be I64 question mark. Well, I said it would be optional, and I think it's probably best that it's optional, and that way we can yeah, kind of allocate it when we kind of need it. We also need open state. Maybe we'll have it closed state, and this can be a bool. And I think can we have like initializers like that? I'll just double check that. We'll just run the example. It looks like we're building, so that's alright. So we'll have a function to parse this. We'll take in a non-string, we'll be throwing, and we'll return a valve. And this will basically parse this input and do it. But I think I also want to take a mutable valves reference, which is going to be type valve, because the valve that exists might actually already exist, if that kind of makes sense. And I'm wondering whether we actually want this to be a dictionary from string to valve, and I think that is how we do that. And this type will be that, I guess. And here we probably just need a return valve so it can compile. It doesn't like that still. No, we want not comma, we want colon there. Let's have a look-see at source jakt, then samples dictionaries, and like this will probably tell us. Right, so it is square brackets. So that probably means that we want square brackets is that one, square bracket, and two square brackets, and I'll change the other type in a bit. Alright, so this doesn't like it. Yeah, this that's right. But this one, yeah, we had to do like this dictionary of types string valve, and that one like that. So they'll probably let that cool. And then for the type of this function, we will take in that. Cool, so that's compiling. So on each line, we will basically want to. I think I also want to. Well, like this can like potentially add it to the dictionary itself. Yeah, so I think we can just go parse valves and line like that, and maybe we don't actually return anything like that. Except it's not called parse, it's called a valve. That, and maybe at the end we can print out whatever our valves is. Valves like that. We can't do that because it's private, that's because it's a class, so we'll just go public like that. Right, so now we kind of have a bit more of a thing. Right, so how do we go about parsing this? So I probably want to have like a split on like, yeah, probably a split on just spaces maybe. Yeah, so I might make that split equal, we call it s dot split on a space. And here we can let name equals this split of 1, and we could probably do let rate equals split of, what is this, 0, 1, 2, 3, 4, and we want to split that on equals with that brace, and then we also probably want to, and then we want to get the first element, then we want to split this on semicolon, you get this first one, and then go to it, and we want this to be an I64. Right, so that's our rate, and then we also have like all the paths. So the paths are going to be a certain length depending on how many we have. So what was this? This was the 4. So 5, 6, 7, 8, 9. So paths start at 9. Right, so how do we go about getting all the paths? So first off, we should probably see whether we have if valves.contains name, then yeah, we probably want to have init valve equals can we like not assign it at the moment? No, I'm not sure we can. But we also up here need a, we'll call it tunnels, and this can be a list of valves, that list of valves like that. And I think this is where we like couldn't do that sort of thing, because in fact we can get rid of this code and see what it says. Yeah, so we can't initialize inside a non-throwing scope, and like interestingly, if we call this as a struct, right, I thought that was gonna be fine, but yeah, so we basically have to do that. So if valves contains name, then we want this to be yeah, I think I do want like a mute valve, and this can be a type of valve question mark, and it can be none to start with, and here it can be valve equals valves dot get name, I guess. Otherwise we can create a new one, which we can do like that, and tunnels can be like that. We could probably create that tunnels. Mute tunnels is a list of valve, and it can be nothing for now, and then we can just have that. And we probably also want to I think we can do something like this. Name, yeah, equals valve, like that, and we can just have a square brace there. Right, so at this point, like, and I think we need to do something like that, because valve is an optional type, so we do need to have a few bangs as we go about it. So this probably compiles, yep. So now we need to kind of build up that tunnels. We should probably maybe build up the tunnels here. Yeah, and here we want valve bang dot tunnels equals tunnels. I wonder if it will let me do that. It will, cool. Or it won't. No, it won't. Non-console value reference to type. Right, so we're that is like on that one. We'll just comment that out for now. And we do kind of add some stuff, but then we get a bad return code. Not all the time, cool. So that's just that weird thing. This is kind of weird. Do we need like a bang there? I wonder. What if we just have that? Oh, I wonder if we need a bang on the. Yeah, so that's just. Yeah, I think we want to do that because we know that it is in there. That's the button I want. Can we do that? Gosh. we use the dictionary in other places, I wonder. Right, so this is... So it's like returning an optional. Yeah. So I feel like if we do that, it's got a lot of warnings. I wonder if we need something like that, and have like pointers to it. I don't know. Something like that. Gosh. What if we go bang there? That looks slightly better. And valves is... do we need a... what is that? Set name to be that. And do that. That looks somewhat better, but it's still errors. Yeah, it's still errors. Gosh, who would have thought? Maybe I'm overthinking this, or hitting some walls with the yachtness. Yeah, I think I will pause momentarily here and come back to this and try and work out how to get Yak to do my thing. 'Cause yeah, I'm sure I've done this kind of before. I remember I did like, we did like optional there. Yeah, I wonder if we do optional. And anyway, I think I'll leave it here and come back to this. So yeah, see you. Hello and welcome back to the same video, I believe. So I've got this compiler error fixed now. So I did it using a dictionary to an optional valve, and then unwrapped it when getting it and then setting it. And this seems to now compile and print out everything that we have. So one thing that I notice that we don't do is we don't set the rate equals rate, and we probably also want to do it there as well. And so now this should, it doesn't like that. Are we not allowed to do that? Unknown member rate, flow rate we call it. Shall I just call this rate? And yeah, that will be better. Nice shorter name, because I'm going to type it all the time. Alright, so now we should get all these things in. So CC has 2, BB has 13, yeah, that all looks good. Well, 2 look good, HH has 22, FF has 0, that is correct. So the tunnels we are not parsing just yet, so we're still working on the parsing. So how we might go about getting things. So we have like we can look at this and then basically keep on going from there. So maybe for I in 9 dot dot and then split dot length because it's a string, so it's length. And gosh, I didn't want that. And so here we can have we can get our split and get I, and we can do another split on a comma and just get the first one. And in cases where there aren't a comma, it should have just a split of length 1, and so there will always be 0 elements there. And I think we don't need to kind of do anything, but we can maybe call this valve. What do we want to call this? We'll just call it vName, I guess. And here we want to basically check whether we already know about it. So if valves dot contains vName, then and maybe no, we don't need to actually get it. We can then just go tunnels dot push and valves dot get vName bang. Yeah, and I think they'll do that. Otherwise, we need to let v equal valve, and we can just probably do like that maybe. We might not be able to because of the tunnels. So maybe we'll need to go let t of type valve equals empty and tunnels can be t, and then we can go tunnels dot push valves just v, but we also want to go valves similar to this set v name to be v, and so they'll kind of add it in. And so if I do that, I didn't like that. Do we do like some there? Right, let's go up to the top. We can't find the length on. It's not a string; it's a array. So we want size there, and that is probably because it doesn't know that. So that's fine. It's still just that. Right. So it doesn't like this because we. Do we need like a double bang there maybe? Bang bang, never had to do bang bang before, but maybe there's a first time for everything. Where do we start this? Right, not sizes, just size things. Right, this is looking better. Right, so it doesn't know this because v is not optional, so maybe if we just do that, I guess. Didn't like that. Expected optional valve, but got non-optional. So I wonder if we have like some that. I don't know if that is like a thing in jakt. It does seem like it is compiling. Got a crash, getting fairly reliable crash. Build day, what are we up to 16. So we like print out a bunch of stuff so we can kind of see where it crashed, I guess. So after JJ, this can maybe scroll back. So after JJ, we print it, and then we're like trying to print the valves, I guess. Maybe I can just do a print line here, because it seems like it is kind of crashing trying to print out the valves. Yeah, so it's crashing when we're trying to print out the valves. I wonder if we can go for the in valves and print line v equals that, and just print out the valve like that, and then maybe get rid of all that, and run that again, and maybe see why that is. Yeah, so like the formatter for the valve is not liking it, because I guess it's like endless. Yeah, it's like kind of recursive in a way. I think the tunnels, we can kind of just store the string because we're having a like dictionary of string to a valve. We probably don't actually need to do this, and we can do that and then just add vname, and not have this double bang bang, and then we won't kind of have that circular reference because we've just got a and then this can be a string. Yeah, that looks better. And we'll keep that for loop down the bottom because it seems like a bit better, because it'll print out each valve on a single line. Right, so we don't need this, and potentially we don't need this because we can kind of just look it up. And here we have our thing of all our valves. And here we can probably go and name the, because it is a dictionary, so we get two values out. Oh, I didn't like that. It did not like that. Probably because we need a brace around that. Just a bracket, parenthesis. Right, so this should get us the right thing. So when we're CC, we have a valve rate 2. Where do we have CC? Rate 2, and it leads to DDMB. DMB, that looks good. And B leads from C to A. This is like ABC, so I probably can do it here. E would be A, B, C, D, E. So E goes to F and D. Sounds good. A goes to D, I, and also B. That all looks pretty good. So we've kind of parsed all the valves. And I think the valves kind of need a like set of neighbors. Well, like I kind of want to get this A star kind of going, and to do that we kind of need a like node class as well as the valve, and the node is going to be like a node in the search graph, so it's kind of going to be like each minute has a new node, and yeah, maybe as I'm talking I can kind of just flesh that out. So we can have a node, And a node is going to have a list of open nodes, I guess. Open valves. No, we're going to have a current valve, and it's going to be a valve. And potentially we need to do something like that. And we're going to have a minutes, and that is going to be I64. And that can just be 0, I guess. And what else do we need? We need a list of open nodes, I guess. And so I guess this, we don't really need it on the valve. We can just have because we're going to be throwing around this valve as a class, we want to be able to basically mutate it, we want to change whether it's open or closed, but depending on which node it is in. So I think the node need to keep track of open valves, and this can be a list of valves like that, and we probably need to do something like that. And how did I do it for tunnel? We just don't have a default value, so when we construct it, we need to kind of set that to the right value. What else do we want to have? We kind of want to have a score, maybe we can just have released, and that can be an I64, and it can start at 0. And I wonder, so these are all, I think this can be a struct. Might make it maybe a bit easier to kind of go and do things. And so what am I thinking here? I also probably want to just copy this A star at some point. I think maybe flesh out this node a bit more. So we're going to have a function neighbors, and it will probably take this, and it will return a list of node, and we can probably just return rect, and rect can be rect type node, just be that, and we probably will need this to be mutable, otherwise we will never be able to add to it. And we probably also need a function is complete, and it will take this and it will return just a bool, and this can probably just return this dot minutes equals 30, I think it was, 30, boom, that's not what I want. And we can probably have function f, which is going to return I64, and that is probably just going to return the release so far. And so that can just return this dot released. And we're going to have a function h of this, and that's going to return I64. And the h is going to return the estimate of how much will be released. Well, how many more steps to the goal. No, it's not how many. It's kind of the expected score of where the goal will be. Like the expected cost to get to the goal, which here we're wanting to get the biggest thing. Yeah, I guess A star isn't quite going to work because if we're going for A star, that kind of finds the minimum value, and we want the maximum value. So yeah, I guess we could kind of change this A star to, because we get the lowest, we could probably, instead of get lowest, just get the highest, I guess. And when we do this, like setting it, we would check whether it is greater than, and if it's greater than, then we'll add it, we'll update it. So we're kind of just like flipping the A star to be that, and we might start the G's and the S to be a big value to start with. Yeah, I might have to think before we do that. So for the estimate to the end, yeah, because we will kind of want to pick out the thing that looks like the most likely candidate. And the thing with H is it has to be atomical, incremental, some like fancy word for it. It basically means that it has to underestimate the path to the end, not overestimate. If it overestimates, then it will just be wrong. Which I think, because we're like flipping it upside down, we want it to do the opposite. But kind of what we can do is mute ret, and we can just start it there. And for each of the open valves at the moment, we can, so for the open valves, we can add to ret this, we'll need this there, this dot minutes, .30 minus, I think I kind of want another function, minutes remaining, and this can return return 30 minus this dot minutes, and this can be minutes remaining equals 0. I've got an idea that the part 2 might be like, it's actually going to last for 60 minutes, and then you can do that. And here we can go minutes remaining, and we want to times that, I think it is. Maybe let's make this a bit bigger. Right, so yeah, if we got 28 minutes remaining, then we just times it. Cool. So we will times it by whatever v dot rate is, and that probably means that we need to make this public. A better way to do it would be public function rate, and it can return an I64, and it can just return this dot rate thing, and we need this. So then we can just go like that, and at the end of this we can return the ret, maybe do a test compile. Alright, so this doesn't do it. We need to throw on neighbors because we create an array. That's alright. Throws. It doesn't know minutes remaining. This dot minutes remaining. Can we get this to that and paste in there? Because we don't actually return what type it is. Interesting, it didn't complain that it right. Maybe we'll call this flow rate. So we can't have a function that overloads what the member is called by the looks. That's all good. Right, so that looks good. And the output doesn't really change because we haven't really done much there. So for each of the neighbors, so we've got like two choices. Either open a current valve for 1 min, or move to a new node for 1 min. New valve, I should say. So those are our two choices. And so I guess if open this dot open valve dot contains. Now I think, yeah, I wonder if this will kind of work. This dot current bang, we do a thing. So I think if not that, we want to open the valve, and when we open the valve we don't actually release the pressure, then it's in the next minute that we do. Yep, so here we would just go so here we kind of want a copy of it. Mute node equals this dot clone, I guess. Function clone this, and it returns a node. And here we can have a mute node ret equals node, and maybe ret dot current equals this dot current bang, and actually we just don't need to unwrap it, I think. And here ret dot minutes. Well, in fact we can probably go current can be this dot current, and I think if we kind of do this kind of layout, because we can do some stuff just as is. Minutes can be this dot minutes, and released can be this dot released, and here we can probably have a mute open, which is going to be a list of valve, and it can be nothing. And for the in this dot open valves, we can, I'm going to call this open valves just to make it a bit easier. We can go open valves dot push v, and here we can probably just return this, return that, and maybe go to there, and here we can go open valves, and that all looks good. So we'll clone the node, and then that node, this is when we are going to open that valve. So node dot minutes plus plus, and we're also going to go node dot open valves dot push node dot current bang. Yep, that makes sense. And the current will stay the same, and so here we can go ret dot push node. So that is one option. The other option is I'll get rid of that. So moving to a new node, we will want to. This, I think we will need to take in this mute belts. Wow, it doesn't need to be mutable. We can just go like this. Yeah, and we'll just pass in that vowels, and we have a set of the vowels down there, and then each of, I guess like this current, we can probably just have strings for all of these things. And in this we can pass in that, and here we will get valves dot get v bang dot flow rate. Is that what we want? Yes, I think that's kind of what we want. Because otherwise we like kind of don't know where we are. Valves dot get this dot current bang and bang on that. So we now have a valve object, and then for the in valve dot neighbors, and I think because of that we also need a public function neighbors, and takes this and it returns a thing of string, and I guess we can return this dot tunnels. Now, like, I don't want to like modify that, so maybe fix me this may allow modification, because we're going to like basically return a reference to an array, and we could potentially change that. But yeah, so this will return us all the strings, and so that's going to return a bunch of strings, and so we just need to make a new node for each one. Go back up here, and we're going to spend a minute doing whatever, and we're also going to set the current to be v, so that we have gone there, and then at the end we'll just return ret. So I think print line neighbors, we don't really have a start node yet. Well, the start node is just going to be, I like this. So mute, let start equals node, and our current is going to be AA, and the rest can just be nothing, though that needs to be something. Let open be a type of string, and that can just be that, and open valves. It's kind of annoying that we have to pass in that, and we can't just go boom. such as it is. I mean, we could do function start node, and it just returns a node, and we can obfuscate this kind of behavior, and do that. That's not where I wanted to go. Where was I? Here. And we can just return that now. Return node that. And it'll be our start node. So if we go let start equal node start node, yep, and we could probably go print line start equals that and start, and maybe print line neighbors, and then for in start dot neighbors, and I believe we need to pass in valves. We can print line in equals that. Let's see what this does. It doesn't compile. That's alright. We can just work it out. Right, gosh, where do we start all these errors? I think this might be not that one. Yeah, we kind of want this one, but for 16. 16 like that. Right, so we can't do that because we don't throws on start node, so we can throws on that. What else don't we like? We can do that. It doesn't like that. Oh, we've got a C chart. We need to, I keep tapping that button that I don't want to tap. I should really disable on my keyboard. My page up and down, like right next to the up and down. So that is what is happening there. But yeah, here's where I am. I normally use like not up and down, but in a different editor to my norm. Right, so it doesn't like that on clone, so we also need to throw there throws, which probably means that neighbors already throws. That's cool. Open valves. Valve.neighbors. We don't know. Do we not have a neighbors on a valve? We should have a right, so that is a bit confusing. And all those are just errors on that. And it couldn't get flow rate as well. Is it because so a valve has a function neighbors that returns a can we just go through tunnels? this may need like a double bang. Yeah. Neighbors. So the first bang is kind of unwrapping the get, because the get could return nothing, and then the second bang is unwrapping this because we pass in optionals because it compiled and I got it compiling. Right, so this flow rate one probably just needs a double bang there. Double bang. That looks like it might be compiling now. Right, so this is doing some stuff. Right, so we get a start node, that is where it is, and neighbors seems to only have one thing in it, which is incorrect. Because neighbors should also have print line valve equals this valve, and print line neighbors equals and valve dot neighbors. I'm wondering whether I should rename neighbors because it is a bit lengthy to type. N could be a better word, but it's not as descriptive. Yeah, so neighbors, valve is that, and neighbors has 3 strings. Yeah, so I'm unsure why it is not going through here. Print line new node equals this, and node, I guess. Yes, I wonder. I wonder indeed. Yeah, it's printing out these new nodes, and we never push it. Rep dot, gosh, rep dot push a node, and that means we can probably get rid of that and these ones, and go back to this, and this should hopefully show that we yeah, so we get some neighbors for that start node, which I wonder is correct. So we can either spend I kind of want to print line n.f equals that, and n.h equals that, and n.f and n.h, and I believe we need to send in the valves there. And that means that this one should have like well, actually no, it won't have anything. Yeah, it should be 0 because A has a flow rate of 0. I wonder if we could just temporarily make that, say, like 10. Oh, that isn't what I wanted. And now, yeah, so our H kind of went, so we spent a minute opening the valve, so we have 29 minutes left, and then for those 29 minutes we have basically one valve being open, releasing 10 at a time, so we get to 80. Yeah, that looks pretty good. So we'll change that back to how it is, and like we could, not that one, this one, we could probably even like go a second level deeper. So for maybe we can call that N1 and N1 neighbors, and pass in the valves, and in here we can do that and that. And maybe we can also print in this n1 equals this, morals equals that, and they'll kind of step through like 2 sets of neighbours, and hopefully we should get like some more interesting F's and H's. We get 0 for most, but this one we don't because we opened D and we opened B there. So yeah, that's kind of looking good. So it kind of shows that we can step through, work out the neighbours of a search node, graph node of this kind of search problem, and from there we should be able to apply some kind of algorithm to basically work out the answer. But for now, I think this is a good opportunity to just stop here because we've kind of parsed everything, and yeah, we've parsed everything and we've kind of set up this node structure with neighbors and the kind of heuristic functions. So we should theoretically be able to kind of plug in the slightly modified A star to find the max value of all of these in the next video. So for now, see ya.